Today we have with us Dr. Devrajan. We will have a keynote address by Dr. S. Devrajan. Just to speak a little bit about Devrajan, from my personal behalf, I feel he is one of the current generation doyens in technology in India. And he is basically a mechanical engineer with an MBA and a MS in manufacturing systems and also a doctorate from University of Warwick. He was awarded the prestigious Rolls-Royce Award for Excellence in Manufacturing Concepts and Implementation in the United Kingdom. He is working with TVS Group for the past 29 years and presently as head of the production engineering in TVS Motors. He has worked in setting up facilities for press shop, weld shop, painting plants, heat treatment plants, machining and steel and aluminum engineering parts, assembly lines, and has led many projects in TVS Electronics. Presently, he is contributing on lean manufacturing systems, TPM, just in time at TVS Motors. I would say other important factor would be that he is highly innovative. He constantly he makes changes in process elements in his machines, in his processes in his company. He has to his credit many new processes that he has introduced in his company, which we can learn out of. And as well, he is interested in sports. He is a people's person. He always promotes employee involvement in technology development. That is one of his enduring success factors, I would say. And we have fortunate to have him today, and I am sure that he will scintillate us with his insights. Thank you.
Thank you. Thank you. Good morning, ladies and gentlemen. Thank you, Umesh, for a good word about what I'm trying to do. Today's topic, I'd like to share some of the technologies happening around. It's both practical and some of the thoughts which I have for the future. So this is a challenge, and probably the challenge remains on a continuous way. We talk about machine tools, we talk about the automation, and basically in terms of changes, I'd like to touch something about two-wheeler industry, automobile industry as such, and the key challenges faced by us in a regular way, the growth of toolings, the challenges of system manufacturing, extending beyond small m, extending beyond machines, machine tools, to an enterprise level, how it can be a transformation. That will be my takeaway, and that can be one of the points for discussion today. And believe me, this is not rocket science, but definitely on the basic science of every activity. And as TVS, we strongly believe in systems, and we believe in learning on a continuous way. I represent TVS Motor, and we have a long journey in terms of automobile industry, two-wheeler industry, and many of you or all of you are our customers today. So we started in 1980, extended on mopeds, scooters, with innovation of every area. Today our mopeds are considered as a LCV on two wheels, because people take the goods, people take their family, and it's growing in the market. And of course, motorcycles, we have plant in Hosur, nearby. We have plant in Mysore, Himachal Pradesh for the north, three-wheeler plants for starting three-wheeler, and for the Asian market, we have an Indonesian plant. We are growing. We have done 2.2 million last year, and we continue to increase and improve this year. We are expecting our output in a line is something like every 24 seconds a vehicle has to roll out. So it's a mass production areas. But all the facilities are there. So I'll be touching something about all the areas, even though I'm talking about metal cutting. Because industry involves all the areas, including painting, including assembly areas. So we have products of moped, I mentioned, scooters, motorcycles. We touch every segment of the customer. And we strongly believe mobility is need of the hour for the country, and that will take country forward. So this is the trend, or this is a change, and this is the industry we are in today. But basically, we should start with vision, talking about the return to the stakeholders. We are all working towards customer satisfaction. In my topic today, the main customer is an operator. But finally, we're all working for making the work easier for the operator. He is the final person turning out the product for you. So we need to ensure that we are making the work easier. Of course, we need to take the vendors into consideration and employees' quality of life. To make this happen, we need to have core values, which we strongly believe in TVS core values, starting from the basic values to the cultural values and creative values. We need to say how we can be open and how a factory can be transparent in informing what's happening in the factory. So you're all welcome to TVS Motor for having a look at it. But we are in the starting point. Whatever I'm mentioning today is a first step in a big journey. We have gurus like CN here who has helped us in all our areas. So I'm trying to say we are just stepping in every area of improvement. Let's compare what's happening to the industry today. India versus China, for example, and opportunities we have. We are, in terms of the personal mobility, we are the lowest. That means to say we have a huge opportunity in India as a product is concerned. We are consumers itself, so there's a huge market. I think the only country where we have got consumer market and the producers market too. So we are a market in which the ratio is very low. We can grow, and that's the reason why majority of the multinationals are coming to India, setting up the facilities here. So we have a huge amount of market here and good amount of facilities which can be developed. So there's an opportunity. So if you really compare our growth, compared to our population growth, compared to our changes happening, we are growing. Definitely we are growing. If you take 5% or 4.5 or 6% per year, we are growing. But we should not be complacent. Is it enough for us? Is it enough? If you really compare what's happening to China, it is vertical growth. So we have an opportunity as industry, as a consumer in India, and if you just compare what's happening in China, we have a long way to go, but there is opportunity. So we should not lose this trend and say that we are complacent, saying that we're growing 5% when European markets are not growing. So that's a major topic. We should know what's happening to the environment around. So there's a huge opportunity. India is growing, but not enough. But that's a gap in which we can build and improve. So we have many priorities. For example, job creation, at least 10 to 15 million job creation per year. But growth is an important thing for us. These are the priorities as a manufacturing hub. I did mention about the opportunity as a consumer. India is young, so a lot of opportunity for the new entrants to come in. At the same time, a good manufacturing base to make this a manufacturing base and export to other countries as well. So we survive? I think the most important thing is how responsive we are for change. Changes are happening. We should be having a knowledge of what's happening around. We are growing, we can grow forward, but we should be more responsive for the change which is going to happen. So one major thing, which I'm not going to talk more details today, but definitely is the people. The challenge of change, how we can make innovation. I was talking morning also here, how well we can bring a teamwork together, how well we can bring the people together, and people will make a difference. So whether it's young or old, the demanding customers, and that can be done only through our products and services, the way we manufacture, how it can be taken. So India is the next manufacturing hub. I think that's the topic in which everything is changing today. So if you really see what's happening in 1980s, where only 40,000 cars, only few cars were available, and no ancillaries, and a lot of license and permit charge has changed today. And more than 2.5 million, it increases every year. The 80 billion of turnover of any company which you take, whether Maruti or other companies, it is growing. And with all the FDI coming today, I think India will grow in the liberalization schemes. But what's happening to the customer? It takes 12 to 14 months for a vehicle to bring in parts, 6 to 8 months. But still, a lot of equipments are imported. Many things are changed from 10 to 14 months. We have lead times to customer, which is still high. So we need to bring down the lead time to the customer. So these are the challenges it's happening. So challenges in terms of competition, global market coming into here, the India getting younger and more demanding in terms of the requirements. Fuel prices are continuously rising. The margins, in fact, we don't have control into if you take a final product cost, we don't have control on the final price of the product because it's decided by all of us as a customer. We don't have control on the material cost because it's decided by a lot of consortium happening in the steel industry. What we have control is only around 5 to 10%, but we have to reduce waste. We have to bring that 10% much more profitable. So again, and it should be applied to the supply chain and in terms of rising aspiration in terms of IR. So it has got, as I mentioned, lead time reduction is one of the key challenges we have. Productivity improvement. Key is flexibility. And the cost of ownership, how well the customer sees your product. If you say a moped, how well he is happy to have a moped with him, which can give him a livelihood, how we can give him mobility. So it's important that we know what are the challenges in business, what are the challenges in manufacturing. So, and of course on environment, on energy, how well it can be much better than what you're doing today. So how are we going to do forward in this? Many things are today known. Six Sigma, lean manufacturing, TQM, TPM, and many of us are following it up, and we are calling it the modern management system. Is it modern? It is not modern. Still, we apply it to the business-oriented manufacturing. We have to ensure that it is getting benefit for the company, benefit for the enterprise, and to the community we are in. So it's a business-oriented manufacturing. To make business-oriented manufacturing is a base. I always strongly believe that we are all working to make operations easier. Any industry you take, whether software industry or automobile industry, it is to ensure that the person doing the job does it better. Hence, manufacturing operation is the core activity. And all of us are helping manufacturing industry. As a machine tool, as a cutting tool industry, we're all helping. And I strongly believe that if manufacturing operation is efficient, all other operations are efficient. If not, the other side. So it's important that all of us are working in a very important segment of the industry, where business is changing. We are all working towards a manufacturing system which can bring in the best in our operator and to the enterprise itself. So if you really go to systems-driven engineering, lean is one of the key areas where we are talking about reduction of waste and eliminating the wasteful practices. But nothing happens if there is no framework. So from the awareness on employee involvement, fires, flow manufacturing, one thing I learned from all the gurus whom we have gone through is have a proper structure, have a proper overview of what you're going to get. Then work on improving that area. Instead of saying I want to do only an improvement area, unless we know the global picture, unless we know the overall framework, there's no point going into improvement immediately. So we need to go the base work and awareness, fires, level production, and each has got definitive steps. And it is not so easy to say that we'll just follow and get the results. We need to go through the steps, but once you maintain it, you'll be able to have a PDCA and sustenance of what you have done. So again, this is an improvement cycle which we've got PDCA, but in TVS we have extended and say, what is the dream we have got? As I mentioned about the overall picture, what is the goal? What are the images you have got? We changed from PDCA to TIP PDCA, saying that you need to have a target. And believe me, I've not done all great things here, but trying to say what are the methodologies in which you can take it to the next step. So in auto industry, we are trying to build in the world-class automotive manufacturing in India and for the abroad. We have OEMs, the tooling vendors, the part vendors, the equipment manufacturers. But if you really say a lot of import contents are still there, how we can localize, how we can make it here, how we can make it much more better, it's a huge opportunity. There's a gap, there's an opportunity. So how to bring in the localization of the value chain? It's important for all of us as an industry. So we are working closely on how to make this here we have our own machine building, how to make the innovations here, how to try out, and there's no stoppage of these trials. We need to continuously improve, continuously try, improve, and then go to the next step. So market drivers today, as I mentioned, customer base is expanding, and skyrocketing inflation we have got. Do we have any winning formula? Believe me, it's only a hard work and smart work in which we do is a winning formula. So I'll take it next step in details. So if you really say in Indian market, a lot of things happen from the customer complexity and the product complexity is changing. Indian auto industry is changing from being a supplier of components to tier one, definitely as a subsystem. And a lot of overseas acquisitions happening across from exports from India, greenfield overseas products. And it is becoming a major thing for the Indian suppliers. So challenges today is in terms of quality improvement, consistency of manufacturing of CPK more than 2, mean time between failures and mean time for repair, improvement, contamination in the engine products as well as automobile concern, and the reliability is changing, and focus on cost reduction, enhance utilization of the plants fully, because India fluctuation is there, how to utilize a plant more, how to make automation as well as automation simple, okay. And enablers of the automation is in terms of small footprint and in terms of side door opening, gantry and robot interface, eliminate some of the process itself. So there's a threat to the machine tool industry also, how we can eliminate machining itself, how we can get net shape forming, how we can eliminate painting, how we can eliminate welding areas. This is a technology thing continuously happening in the automobile industry. There is no stop. It's a continuous changes, continuous improvement happening. So we need to understand what's the drivers and the challenges. So we strongly believe that we add value not as sequential, definitely as a spiral. Each area from designs for development on in terms of the discovery channel, in terms of the market insights are concerned, we can add value, and value is a spiral. Each area you can spiral PDCA and grow vertically, like I mentioned about in earlier slides, how we can be improved and how we can be growing. So it's a spiral, is applicable to all the industries, machine tool industry as such, as well as on the automobile industry and chemical industry as well. So we feel that in competitive world, we have to go from Indian standards to global standards, and it has to be innovated at every cycle in terms of design, development, delivery, and we need to understand the base level. Like I mentioned, overall framework is going to be very important to go step by step in the improvement phase. So what are the machine tool challenges we have got? We have got challenges in terms of fixtures, cutting tools, automation, systems, cutting fluids, inspection, gauging. All of things are happening to make it cost-effective machining, cost-effective delivery of the products to the customer. So machine tool is a heart. Machine tool incorporates all the areas of involvement. It's not only a machine. What are the elements which is involved? It involves people also, how well it can be taken to the next step. So we all working today in many of our industry on cycle time reduction. I think applicable everywhere. We say how to reduce NVS, how to optimize the utilization of the machine, reduce the rapid feed, reduce the feed distance which is there by masking some of the operations when especially F&B and zero in terms of the homing operation is concerned. We're trying to work on elements of work, make it zero, how we can improve our machine time reduction. And of course, manual time reduction. This is the focus all industry is happening here, even in automobile industry. So is that enough? I'll come back to this slide again. So in terms of development of toolings, we changed from SPMs to CNC, and the cutting parameters increased dramatically. Today, modular toolings as well as on the PCD, multi-step, PCD, especially on the ceramic and CBN, it is changing. Changes in the cutting tool industry is focusing us to more improvement in the machine tool industry itself. So we have to improve our machine tools too. So if you see modular toolings today, how we can combine many of the operations. These are some of the examples from TVS Motor. How we can bring in the multi-step PCD reamer for aluminum bearing boards, especially crankshaft boards, how we can be. This reduces at least 4 tools to 1 tool. We have been using 4 tools for many number of years, and it has been apart from how we started from Suzuki. But now it is challenging, and how we can bring to 1 tool itself, how we can bring down to number of machines. So it's one important tool, one of the examples which I like to share. Similarly, on the replacement heads, we are taking very strong steps in say how we can make indexable inserts, even in a boring bar, even in a, especially on the wall seat machining of cylinder head, how we can be improved. This is on the replacement head. And especially on the wall seat machining where CPK is extremely important, it has improved the tool life by 30% by indexable inserts. Similarly, for quick fit clamping, for example, reamers, different cycle times reduction, and how we can have the quick fit connection for the reamer and changeover between one takt time. No time difference between one model and another model. We should be able to make the different models in the same line, which is going to be a challenge for us. Okay, this is the area where we are trying to work on all the reamers which we have. Similarly, in terms of, like what I mentioned, the CBN insert technology, how we can be very important in productivity, what we feel is improvement of quality. Once we improve our quality, as you improve our tooling, the productivity definitely increases in many areas, in terms of scrap production, in terms of consistency of output. So we found both CBN and using the 4 cutting edges and single inserts for many of the angles, and many of the small things which you're trying to do in TVS Motor is putting ourselves in confidence and putting ourselves into challenges ourselves, how we can take it to the new steps. The cutting tools trend over a period of time, years. We started with high-speed steel in some time earlier, now multi-step tooling. But there is a threat for ourselves. We are saying whether we can bring in laser cutting, whether we can bring in the change to non-conventional machining. So we are saying how well we can change, how we can be near cut. So cutting tool development is happening. At the same time, what new technology is coming in to this area, we should be aware. And we should try to, that's why this is a slide which is important, which is cutting speed improvement. At the same time, can we eliminate it? Is a challenge we are facing today. So second thing is in terms of fixtures and the flexibility. So you're trying to develop tools or fixtures which is easy for implementation. We have tried a lot of things on existing machining in terms of the most critical thing for us, which is an enemy for us, is the burr. So how to keep our fixtures clean, how to make it multi-model, and how to make it still better. We're trying to work towards an improvement in the fixtures where is an internal clamp, and how we can make the fixtures, each element of fixture. And in fact, one of the major concerns told us, burr is a major thing. Why do you create burr and eliminate burr? Is a thing which is taught to us from our, the CN also taught us very much more detail. The question looks very simple, but the answer is very, very deep. It's very difficult. Why do you create burr and then try to remove burr? But burr is the main enemy for us in terms of the fixtures which we have, in terms of the elements which we use. So we are working very closely to every step to eliminate or reduce the burr. So most important for all the industry today is flexibility. So once we met one person from Toyota, he said, I'm making a fixture today, which is used today. These are 4 elements I've got in my fixture, which is used today. But another 4 elements, I've used it, but I don't know what new model I'm going to get. So same thing is happening to us. We need to be ready with the current models, as well as the next model, which you don't know what it's going to be. So flexibility is such a tricky area in which we need to be ready. So how we can be helpful from the fixture angle, from the design of the machines, we are really working on it. And I request all of you, whichever you're doing in terms of machine or fixtures or thing, we need to look at flexibility as a major, major improvement area. Similar to the machines today, in terms of the improvement of machines, of high-speed machines, now we're talking about multitasking, which is helpful to get capability of CPK more than 2. If we're able to do many of our components in a single setting, though cycle time will be slightly higher, but capability will be consistent. So then we'll have a much better component to our customer. On environmental angle, challenges are plenty. Can we use a machine without coolant? We are working towards MQL from the process technology, depot drilling more than L by D, more than 13, or we're talking yesterday more than 20, and how we can completely have a dry machining. This requires a lot of patience and continuous effort, both from the tooling angle, from the machine angle. So we found that the cycle time drastically improves. We started this MQL when we had a conventional type of operation of parameters. We found doubling the parameters improves the quality level as such. So the challenge for a conventional way of thinking also. So MQL is one of the major way in which you're trying to work on environment in terms of the coolant reduction, definitely on the quality improvements. Similarly, on the process technology, how we can reduce cutting. So we're working towards the form taps in a major way, and we also learned from the machine tool industry, this form tap areas. We are trying to bring into our automobile and the component supply. It's a huge benefit. The reason is on contamination. I mentioned about contamination. So we can't reduce contamination by draining the oil. We are trying to say how we can reduce contamination by improving the process parameter itself, by improving the process itself. So that's the first step. So whether we can avoid cutting, we're going for forming, going for the other areas, working along with the casting suppliers to say how the core hole can be made much better and ensure that we are able to reduce cutting. So we're working, this is a continuous process and a continuous journey of improving the process technology. Going from the wet machining to dry machining, we have, especially CN drives us through saying that how well you're driving this. And anytime when we have discussion with many of the consultants, we find that we have to learn a lot. And application makes us learn much more. So we found that how to bring in from wet to dry machining, which has got power saving, no waste of oil. We have changed to, especially in hobbing, we changed from dry to wet to dry. But we are still in a learning process. There are a long way to go. But that's the way technology is going. Driving from cutting tools to the cooling agent and how we can improve our entire benefit. We found productivity improved by 100% in some of these areas, and DIN accuracy is much, much better. So driving this is again a hob material change. So it's a intertwined activity, machine tool improvement, cutting tool improvement, how we can able to adopt, how we can bring in the new innovation. It's been a continuous way in our area. We changed from carbide-based sintered hobs, so homogeneous powder metal, and there's a mixture of all the things. I'm not saying everything is now carpet-based. There's a combination of all these areas. One thing which we learned in our industry is have an overall map of the industry we are in. What type of cutting tool we are using, what type of machine tool you are industry using, and what can be the changes and what can be the way in which you can go. So you need to have a roadmap in which, and you should go very systematically into the roadmap. That's learning which you have learned. So next is automation. Automation itself, but in our industry we are saying, are we ready for automation? It's a different way of bringing new machines whether we are ready. So we made a detailed checklist in terms of, I've circulated this, and you can't be just automating what you're doing manual. And we also found that we have to go to the basic designs to improve automation. So these are some of the learnings which we found, and ensure it can be applied. Similarly, we started with simple automation and definitely on burring, because we have to say we have created burr and how we can be made into much more way of removal. We are trying to eliminate, but still not in that area. We are trying to work on the machine element itself. So working along with the machine to say that deburring is happening, and so that it's component burr-free coming out of the machine. And of course, one of the major costs of burr again is on the fixture itself. So again, going by auto flushing coolant, the loading time reduced from 12 seconds to 8 seconds. I'm telling you, each second is important when the overall takt time is 24 seconds. So each 24 seconds, a vehicle has to run out, and saving 4 seconds make a lot of difference for our industry. So in all this tooling we mentioned, we have to keep track of our flexibility. The way industry is growing on now, unless we are flexible, we will be surviving. Otherwise, we will not survive at all. So we should say that we are having flexibility on machining, and it has to from the flexibility of machines to CNCs, the modular gauging, which I think a lot of case studies will be presented, quick changeover between one model to another model, and basically going back to designs for machining input, manufacturing input. So this is one important thing which we need to keep in our mind in any area we are, and this is a challenge on flexibility. So we started with, some of the examples are, we started with horizontal single model machine. We changed to multi-model. Now we have got more than one model in the same machine, in the same takt time change. And the benefits are quite extremely good, but it's only a starting point. There are still more improvements which you can do. We are trying, this is one of the challenges which was given to us, saying that why can't you use all the 4 sides of the fixture? So we are trying to work on this on again an index table or on an SPM. How to bring in machining center on an SPM? That's one more challenge we are trying to work. And it's happening in many of the industries. We also learned, I was in Bombay 2 days back, I also learned 2-3 very important points from the industry which I visited. Every industry is changing today. And every area when we visit, there's a learning which can be taken back to our industry. Similarly, now we are going towards all these areas. What next is going to be? What is the next in terms of machine tool industry? We're talking about intelligent machines. How to make everything as objective as possible. How to make from analog to digital. And online control panel, how to get the quality parameters. Most important is quality. How we can bring the quality parameters in the machine, talk to us, saying that this is the way the component is produced. The component produced in the machine should be first time right. So this is one way of intelligent machines. Next, we are trying to work towards automation. Automation not for automation's sake. Wherever it is beneficial for us in terms of difficult, dirty operation or dangerous operation, how we can classify the entire industry and how it can be changed to the automated material handling. This again, we need to work on the quality of the machine. We can't just automate on any machine. We need to go into our MTBF, MTTR of the machine, improve the elements of machine. And hence, you can do it to the next step of automation. This is the learning, again, on all the challenges we have. Next is on between machines. After a machine and automation, between the entire machining line, how it can be improved on the entire line, and how to change from machine talk to each other, feedback from one machine to another machine so that it can get improvement in the next machine. This is one other area of the improvement. Later on, how we can have unmanned, going for the AGVs, and see that the components are taken from the inventory as reduced, taken from the stores, taken to the machine, the finished parts goes to the assembly line. We are working on that particular, I'm not calling unmanned, but it's a continuous flow in a lean manufacturing area. So the first slide I mentioned about all these steps, I've showed some of the examples in which are going. We are in a track of improvement and growing, but definitely India, in terms of improvement, should go towards this, in terms of unmanned, in terms of continuous flow, in flexibility with one takt time, it's an important for us to work continuously on this. So the roadmap for anyone which can have is cells talking to each other, automatic for part feeding, and definitely we like to interplant or inter-factory talking to each other and say what can be made. Finally, what are we working for? It should be on the business result. The customer is waiting for a product on any product which they want, we should be able to deliver. So throughput time from the raw material to the finished goods to the customer reach should be reduced. Though I mentioned about lead time for introduction of a product, that should be changed to raw material to the finished goods going to the customer. And as changes, how quickly we can make. So this is a roadmap which some of the areas where we are trying to follow. So the basic thing is how we can translate from small m, which you are all today, and many of us also in a similar way, how we can translate to big M. Small m in terms of machine tool elements, machine element. Normally we say forward cutting time, in return we say how we can improve our machining time. We are talking about 20%. That's about all. If you take any value added ratio today, it will be less than 2% in some of the areas. Value added ratio is the ratio of the value added time over total time. Very, very low. And even if you take improved to 20%, which is a target given, but it's going to be a challenge for us. We are only talking small m. How we can improve to load and unload areas, how we can next to the next step is going to be a key challenge for us. Extending to the entire supply manufacturing chain, including the stores, transport inside the factory first. Before we advise anyone or before we tell our customers or our suppliers, we need to establish the lines inside. We can show that this is the way we can do, this is the way learnings which are got so that you can bring people, show, and then extend to the supplier. So next step we found is to focus on, okay, first is on reduction of cycle time. This is tactical. We have to say that we are reducing the cycle time, working on internal customers and extending it to a strategy in terms of manufacturing systems and tools, how we can bring supplier integration, both internal and external suppliers, how we can change from company to the enterprise level, from the tooling and fixturing improvement to the system improvement to the entire supply chain. Supply chain is very important for us because we depend on many of the suppliers, tier 1, tier 2. So we need to extend from internal, after setting up our practice at our factory, how we can extend to our suppliers. And suppliers not even tier 1, tier 2, and a lot of things are going on in terms of how to bring subsystem from the supplier, how we can get fully tested from the supplier. What happens that way is we increase our level of competence of our suppliers also. And we also learn from our suppliers. Many areas there's a cross-learning in terms of technology and what we have applied here, what suppliers have applied. Next focus or the focus which is happening today is going towards tier 1 and the tier 2 and the entire manufacturing chain. So this is another challenge which every one of us are facing in automobile industry. So this causes again from manufacturing systems and tools, internal and external customer, and working towards the upfront, working towards challenges. I mentioned about can you eliminate machining, can you eliminate welding, can you eliminate painting, is always a continuous thought which is coming in. And what are the other areas where we can add customer value? This is not sufficient. The learnings which I've got from the industry, learning which I've got from the industry to the suppliers and to the entire tier 1 and tier 2, how we can extend to our education level is another thought which we have. We're trying to work along with many of the institutes to have the curriculum changed so that the people coming from the institutes are industry ready or industry ready in our company. They come to our company and work so that how to bring the education system which is going to be the base for us for the future. So it's not enough that we work on the machine tool, as I mentioned starting, extending to the automation in our areas, make the model in our areas, how we can bring suppliers to our tier 1, tier 2. We have to extend towards the education and towards the society. So I started with a vision and how we can work on all the 4 areas of the important thing for us from the business angle and how we can go into steps of each area. And some of the examples which I shared on the growth pattern and learning. And every day is a continuous learning for us. And when we listen to some of the presentation, listen to some of the experts coming to us, we learn, get back into our area. But one major thing which I learned is how to make it standardized. Whatever we improve, how we are able to standardize, how we are able to train. Because finally the customer again is an operator who is able to deliver the product of what thought you have got. All of us are here are salesmen. We sell our thought. We sell our ideas in terms in a proper way. And finally, the operator is a customer who takes that thought and brings us the product. So it's important that whether we are in cutting tool industry or automobile industry or chemical industry, how we are able to translate our thought into a systematic way of implementation is engineering, which I learned so many years. So it's important that we bring it back to our education and how we can put into our curriculum, how we can bring the education level up and take it to our future. So we are trying to talk about new opportunities we have, the new challenges we have in the industry, challenges in terms of elimination itself and creating new technology, but we have to concentrate on the customer value, combination of systems and tools, and definitely speed of action. So these are the learnings or the next practices which I feel is some of the experiences which I shared, translating from small M to a big M, which is an enterprise, which gives a company the benefit, and how we can focus on the customer value and speed of action. And no position is continuous, it's continuously changing, and the challenge continues. Thank you for your patient hearing. Thank you. Go ahead. Yeah.
Hello. Good morning, sir.
Good morning.
As you know, we were also involved in as a supplier to you, and we have bought in a lot of technologies, automation, and things like that. See, we were keen to now also think of much ahead technologies like Israel people who are into a system where sitting on your desktop you can go point to point what is happening on every mission of all your 350 missions or 500 missions, or it could be at Mysore or it could be at multi-location, worldwide, global, Indonesia. So this is what one concept which probably people can take advantage. It's not very expensive technology, which we can get in the information from right from G00 to G01. G00 we can't do anything. G01, yes, we can control. It is controlled in a very simple way that the torque of the motor is sensed and then it controls the feed rate. It has got a beautiful application manager inside which controls the feed rates, and this is how the productivity is improved by about 30 to 40% on each of the mission. So just imagine if you have 350 missions, what is the kind of improvement you can have about it. So this is one technology which always I wanted to discuss with you, and we were there at TVS, but okay, I thought this is also a right forum to tell this so that all our Indian people can get knowledge on this and get, this is basically Omative technology who has got a patent on this, but also Fanuc also has got the kind of this technology, but it's one step down, okay. It cannot do MIS there, it cannot have a management system into it, but it can still do as an individual mission the same kind of technology. Okay, so we request you to look at this as an important thing to develop TVS further or any other industry. Yeah. Thank you, sir.
Yeah. I think thanks for the very valuable information. We found that how IT can be brought into all the areas, including to from a sales area. Today we know from using SAP and the IT level, what's happening in one of the dealership in Bihar today at our place. We say that information about what the color which has been sold. So we are using the DMS in a major way. So similar thought like what I'm talking about intelligent machine across the place, we want to extend to the machine. I'll take your inputs and probably will meet you in how we can use IT technology much more. It's important that we use IT technology in the right way. Some of the repetitive work can be reduced and information can be there. We can do much more analysis rather than capturing data. I think it's definitely a good way to take all the machine tools forward, talking machines, getting feedback from the machines, and take the IT in a big way in terms of communication. Thanks for the input.
Sir, as a metal cutting industry, we mainly using all the steels. Basically, every time that quality steel, we feel that it is the trader's hand, because all small kind of people cannot buy it directly from the mills and the quality which required. So every time we are buying it from a trader, even a trader retesting it. If you go and say, then he is showing the mill certificate from the mill, but what is the necessary to again he retest in the machine? We do this is not giving a clear answer, and a fluctuation of that cost. So what your view in the government to take to control, because material is a very certain product, material is the very large amount of contribution in that.
See, we know the industry where we are in. You know your business where you are in. Some of the areas we'll be concentrating on the front end of the facilities. We'll be concentrating on, say, how the sales is. At the same time, to improve the front end, we have to go back into our processes and basics. So I understand definitely there is a variation in the raw material. So as a roadmap in some of the industries, we have to see how well we can have a check before it comes to our place. How we can go to the trader or the manufacturer end, where we can get or where we can have consistency in a source of supply. So I'm not talking only from the machinery industry, it's an entire industry as such. How well as an entire system we can apply from a quality system, from how we can apply from the incoming to the suppliers and check. It is necessary. Otherwise, you will be having a costlier component, scrap going to, or not right component going to the customer. We are talking about customer value in the front. So every step I feel is important that we give importance to. From our manufacturing, from our cycle time, to our incoming inspection, how the component is coming into the to our factory. So probably the focus can be in a phased way that we get the right material into our plant properly. We get, and how we can translate into our supplier who is supplying to us in the same way. Can we standardize some of the areas? Many areas we are working along with the group of suppliers for us, how we can group together and order on a right material. All our vendors we have grouped together and we have a group buy. So we know very important is what you said is absolutely right. We need to get the right quality of the incoming part, or incoming castings, or incoming raw material or ingots. So can we work along with the bigger OEM, and can we have a combined effort? It is possible and it's happening. So if you're supplying to some of the OEMs, for example, it's better that tie up, have a supplier cluster in which you can have a group buying, and it is happening across. And we do it in a regular way in our company. So we need to work across. We can't say we'll buy whatever we get and get a right component. So it's important that we go into that step of which area their focus is going to be, which area we have to make an improvement. So that's one of the learning. And I may be giving you a simple answer, may not be in the right way, but I think the focus should be where the problem is and how it can be improved. That's one of the learnings. Morning.
I'm from Godrej. My name is Ravi Singh.
Yeah.
Sir, we always talk on the manufacturing processes, but we really miss on the material front. We always talk of 4Ms, the methods, the men, always we talk on these aspects. But in such forums and councils, we really miss on a technical expert on the material front. So if we really take up some things where we really challenge the material, how, because finally every machines are, and the methods are finally machining the material. So how fast we can churn the product, because we talk of the Germany and all going into the hardened blocks directly and really reducing the lead time. But here we see really this change, the material person coming and giving us input and giving a big trials. So that factor we really need to put in, sir.
Right. Good. See, I can. I like to answer this point, though it's a suggestion. See, many areas, all of our industry is, we are challenging the basic premise of work itself. Why you have to do machining? I mentioned earlier. So why you are trying to do painting? this turns up a lot of new ideas coming in, turns up bringing up near net shape for a component. We're trying to make it powder metallurgy, working along with our group companies. How we can eliminate machining itself, whether it's gears or whether it's crankshaft. It is challenge happening. Similarly, many things are happening in terms of painting. How we can eliminate painting. And it's happening across. I think we learned it from the industry of which makes, for example, Godrej, this thing itself. How we get sheets which is already pre-coated. So what's happening, we know we are improving. As I mentioned, we are improving this. And there's a threat coming in. Threat saying that, hey, there's going to be a change. Next year or next 3 years, there'll be a change in our entire way of operation itself. Even in our automobile industry, it can change from electrical vehicles coming in if we improve our battery life. So it is a continuous change in all areas. And I agree with you, material front is a huge amount of changes. And there are a lot of many examples. Since I'm talking about machine tool industry, I concentrated on this, but there are many areas in which we are, as I said, we are growing in that angle. We are also in a step-by-step going into our angle. We are learning. So there are many areas in which I appreciate that point, saying that we should need to challenge and say, can we eliminate it itself, That's a big challenge for us. And even the lean machines coming is a big challenge. Why do you want to have a size of the machine? If the size of the component is only around 300 mm, why do you need to have 3 meters length of machine? Again, a thought which is trying to make. And say, we reduce the footprint to less than a meter. That's a continuous way, and that's a good point which you mentioned. We need to know that what's happening in the material front too.
Just one point to add for Mr. Devrajan. There are classic examples in IMTMA itself with the cluster approach, how the material buying, both in terms of cost and quality, can be synergized across different buyers. Even though small buyers, there are various examples. Perhaps if you are really keen, we can contact the secretariat. We can look at how to take this further for the individual benefits as well as the industry benefit. Now I'd like to Mr. Devrajan has been very courteous to be here in spite of his busy schedule. He is off to Germany in the afternoon, so he needs to leave. And we would like to thank him on behalf of IMTMA and present a small memento to him.
Thank you very much. Thank you. Thank you very much.